Everybody, let's find the moments of inertia for this composite shape about axes going through its own centroid over here. Okay, so strategy. We don't know the location of that centroid right now, so let's pick another set of coordinate axes that are convenient, and then we'll use the parallel axis theorem to move it over. So we could pick axes, let's say like over here, or here, or here, or here. It doesn't matter. There's no wrong choice. So I copied and pasted that picture, but I just got rid of the centroid. So how about we pick axes? I think it's good to pick right through the middle because of the symmetry. And then how about just like at the bottom over here? Okay, so we got these new coordinate axes. Let's solve for the moments of inertia about these axes. Then we'll figure out the location of the centroid, and then we'll use the parallel axis theorem. Okay, so I just grabbed this straight out of the appendix. So it looks to me like we can treat this like a rectangle here, another rectangle here, and a third rectangle here. So it's a composite of 3 rectangles. Okay, so I should just leave that up here, right? So it's like a composite of 3 rectangles. So for this rectangle here, its centroid is over here. So about its own x-axis through its own centroid. Look at the appendix. It's 1/12 base height cubed. So let me just write the numbers. So about the x-axis, 1/12 base height cubed. So for this rectangle, base is 0.8, height is 0.2. Everything is meters. Okay, but we don't want the answer here. We need it to be here. So I have to use the parallel axis theorem to move from here to here. So how do we do that? Plus extra. How much extra? This area. So that's 0.2 times 0.8 times this distance squared. Okay, so how far is that? So here to here is 0.1 plus another 0.6 plus another 0.2, so that's 0.9. So here to here is 0.9. So 0.9 squared. Okay, now the middle rectangle, this one. The centroid is over here. So we'll go 1/12 base height cubed, 1/12 base height cubed. So for this rectangle, base is 0.2, height is 0.6. But then we need to use the parallel axis theorem to move here. So plus extra, the area of this rectangle, 0.2 times 0.6. And then how far is this? 0.3 plus another 0.2 is 0.5. 0.5 squared. Okay, now for the bottom rectangle, this one, the centroid is here. So from the appendix, 1/12, base height cubed, base height cubed. The base is 0.6, height is 0.2, and then parallel axis theorem, we need to move this far. So plus the area of this bottom rectangle, 0.2 times 0.6, and then how far is this? 0.1. 0.1 squared. Okay, so this is the moment of inertia about this axis. Okay, so let's keep going. Let me make some space over here. Okay, so now let's find I, y. Okay, so for the top rectangle, the centroid is here. So about this axis, we just look in the appendix. 1/12 height base cubed. 1/12 height base cubed. So the height of this rectangle, 0.2 base 0.8. And it's already at the y-axis. So we don't need to use parallel axis theorem to move it anywhere, we're good. Okay, so for this rectangle, its centroid is here. So about this axis, right here, 1/12 height base cubed. Height is 0.6, base 0.2. Okay. And it's already at the y-axis. So again, no need for parallel axis theorem. And the bottom rectangle, its centroid is here, about this axis, right here. 1/12 height base cubed, 1/12 height base cubed. The height is 0.2, base 0.6. Okay, so this is for the entire composite about this y-axis. So let me move this over next to the other one. Okay, so we know the answers, Ix and Iy, about these axes. But we wanted the answer about an axis going through the centroid somewhere like over here. I'll call it x prime, y prime. I mean, y and y prime are the same, right? So really, we just need to move some distance this far in the y direction. So we need to find the location of that centroid. So where is the centroid? The centroid is an area-weighted mean position. Okay, so where's the centroid in the x direction? It's exactly where it is. Right, the centroid in the x direction is 0, so that was easy. But what about the y direction? Okay, so it's an area-weighted mean position. So there are the 3 rectangles again. And so let's say for the top rectangle here, for the middle rectangle here, for the bottom rectangle here. Right, so this bottom rectangle, the middle rectangle, the top one. So for the top one, where is that? Here to here is how far? 2 plus 6 plus 0.2 plus 0.6 plus 0.1, right, halfway. So that is 0.9. So 0.9 meters times the area of this rectangle. 0.2 times 0.8 plus, where is this? It is 0.2 plus 0.3. So 0.5 times the area of this rectangle, which is 0.2 times 0.6 plus, where is this? It's halfway, so 0.1 meters times this area, which is 0.2 times 0.6. Okay, divided by the total area. Top rectangle, middle rectangle, bottom rectangle. Let me write it like this. 0.2 times 0.8 plus 0.2 times 0.6 plus 0.2 times 0.6. Okay, so for this, that is the location of the centroid in the y direction. In other words, this distance right here. Okay, so to do the parallel axis theorem, let's call this x prime. That's called, and then y and y prime are the same, right? So for x prime, how does it differ from x, the red one? I mean, this one is more, this one is less, because going about an axis through the centroid is a minimum. So for sure this is less, which means this equals this minus something. What is that something? The area of the entire composite, which is this right here. We already got it right here. That's the area. Times the distance between the 2 parallel axes. The distance between this axis and this axis, which is exactly this number that we just solved. That squared. This squared. Okay, so that's the answer right here. Here. I y prime is exactly the same as I y, right? Because the two axes are the same. And we already have that answer right here. So that's done. And the polar moment is just, you just add these two together. Okay, that's an x. Okay, oh, and then I forgot these. Okay, so the radius of gyration, if you have something that looks like, right, so it's this squared times a. This squared times a. This squared times a. Right, so if you have this answer and you have this answer, then that radius of gyration squared is ix over a, and then just square root the thing. Right, same here. Okay, this would be iy over a, and then square root. Same over here. Okay, so hope that was helpful. So keep on practicing this type of problem. This is a good problem because you're using moment of inertia and centroid and parallel axis theorem. So it's pretty good practice. Okay, so I'll see you in the next video.